Today we're going to look at exponential functions. The parent exponential functions are going to look like this. Y equals some constant, some number that never changes for that specific problem, raised to the x power. So we're going to look at the two basic parent graphs that are based on y equals 2 to the x and y equals 1/2 to the x. So let's go over here to look at my applet, and we're going to start off, as you can see down here, where the base is 2. So I'm going to look at y equals 2 to the x. The basic graph looks like this. It's graphed in blue. The key point that you must always graph is this point here. The key point starts out on the parent graph at 0, 1, because when I put in x equals 0, I get 2 to the 0, which equals 1. When x equals 1, 2 raised to the first power is 2. When x equals 2, 2 raised to the second power is 4. And I can calculate a lot more points, and I get this basic graph. Notice it is an increasing function, so we get this basic shape of the graph. It comes along here, it increases and goes up. So the parent graph of y equals 2 to the x is an increasing function. It goes through the key point 0, 1. And it also has one other interesting characteristic, and that is it has a horizontal asymptote. As x decreases without bound, as it gets smaller and smaller, this function is going to approach the x-axis, but it will never ever touch it. When this happens, that's called an asymptote. So this graph has a horizontal asymptote. Notice the blue dotted line represents the asymptote. We always put our asymptotes in dotted lines. And the equation of the horizontal line on the x-axis is y equals 0. So now we need to look at what happens when I change my base to a different number. So I'm going to move this slider here and make my base go up to 3. Notice the graph is still an increasing function. It goes through the key point. It has the same horizontal asymptote, but it just climbs up steeper here, and it's slightly shallower here. And this continues as we make b bigger and bigger. But it has the same basic shape. So now let's go down. Here's base of 2. If I make b smaller, getting closer and closer to 1, it has the same basic shape, but it kind of flattens out the graph. So let's move that back to b equals 2. Now let's look at what happens when the base lies between 0 and 1. The base always has to be a positive number, and we've looked at what happens when it's bigger than 1. Now let's look at what happens when it lies between 0 and 1. So let me switch to my other applet, and here I have the base is 0.5 or 1/2, which is this graph over here. And when the base lies between 0 and 1, notice the shape of the graph. Instead of increasing, it is decreasing. But it still goes through the key point 0, 1. And it still has a horizontal asymptote of y equals 0. And as I change the value of the base between 0 and 1, notice it has the same basic shape. It is a decreasing exponential function. And all the base does, being between 0 and 1, is it affects how steeply it drops in along the curve. So the key thing to look at when you're looking at the parent exponential functions is if the base lies between 0 and 1, as in this curve, it is the decreasing parent. And if the base is bigger than 1, it is going to be the increasing parent graph. But on both parent graphs, they go through the key point 0, 1, and they have the horizontal asymptote y equals 0.